Mic muted for me. No, I guess. Okay. I think it's unmuted. A mic is allowed for you. You have to unmute and then speak. Okay. Okay. Coming back to the discussion. So I have revamped the complete syllabus, the topics. Not a big deal. I tried to align it as per October 2025. So I don't know. I think I did a justice to that. So I would like you guys to go through. I'll share the course handout in the Canvas after this class, along with this lecture slides also, and the code part what we will see today. Okay, just go through that. You can ping me separately, or you can come to the next class also, and then we can discuss on if you feel anything more than that. I don't think more than this is required, and we'll be able to cover. But if you say something else is more important than what's there in the syllabus, we can accommodate. Okay, I'll accommodate. It's not a big deal. We can. I'll think of what can be removed, but I don't think anything, as per my knowledge. If you can educate me on that, I'll surely take it ahead. Okay. So that's one point I want to say. Second point is that. Mm, hmm, Okay. Well, second point is that okay. Intro about me. As I said, for BITS point of view, I'm like last 4 semesters. I'm a guest lecturer actually. I'm not a permanent faculty from BITS uh, because I am working elsewhere. This is a part-time job for me, okay, on weekend, and I work for currently I work with Origo as a engineering manager data science. Earlier, I recently shifted. Earlier, I was with Halliburton. It's an oil and gas firm. Both are US based companies. And there I was more of a principal AI architect. So almost 3 years of work in GenAI, completely in GenAI. Earlier, I was doing more of deep learning and NLP. But then at Halliburton, I was completely into Gen A only. So because that was the boom, right? So we were asked to do work more mainly on that. So almost I can say 4 platforms into production. That's the uh, one statement what I can say about my work there. 4 Gen A systems into production. So that is why I wanted to. I had some time last 5 weeks after the last semester. In fact, I was on a break between 2 companies, right? That's something called. So I had time and I had revamped the syllabus for you guys. Um, it's a very quite interesting journey while revamping because I had to refer a lot of internet resources. Like a few of the things what I wanted to say is like interview questions, right? Including the questions I used to ask my when I recruit. So interview questions on Gene and the topics and job descriptions, what currently they ask for when you wanted to shift or when you want to go higher up in the scale, including my own job description. So it's almost like if you are very keen in learning all the topics what I have mentioned here, so you will be almost maybe 50 to 70 percentage. You can learn what I know. So in fact, I don't know much. So 70 percentage of that is very easy. It's not very difficult. So if you will put in the 6 months, in fact, you will be learning around 70%. Because why I say 70%, not even 70, it's really 50, you can say. Because remaining 50%, I'll give credit to the actual deployment and going into production and doing the observability and monitoring. So that takes a huge credit actually. But the the backend part, the backend development, POC, and the platform, what you should know, some things. So those things will contribute about 50 percentage prior to the deployment itself. Deployment have its own problems, so that's why you should learn the remaining 50 percentage. Maybe you should you, if you want to really go for this, if you're not currently in the Gen A and you wanted to shift to Gen A, you can look for opportunities where you can learn LLM ops, right? LLM ops is a more specific term nowadays, because ML ops is also okay, but again you have to learn little bit different. There are some things which will be different in LLM ops. If you get a course on LLM ops, it will be very good. So that should help you guys. Okay, coming back, okay, let me open the chat. Uh, so that's all about me and my all this work which went before this lecture. And another one thing is that you will find most of the lecture slides which will come for this semester for you guys will be completely revamped uh, for this semester only. It mostly it will never, maybe some slides if I don't get time, maybe I'll copy it from the previous time. It depends on my workload also in office, but I'll ensure it will be new and latest for you guys. Okay, so that's my. It's just a passion. It's not required from me. Not much required from me, but I have taken this an opportunity to deliver it as good as possible. Right. So that's an ethics point of view. Second thing, okay, now coming to you guys. So I don't know how many of you are there in the call. Great, 55 people. That's awesome. Thanks. I hope these many people will be there till the last class. I hope, yeah, I understand everybody is working. So, okay, but at least watch the recordings. I don't normally miss to record, but of course, there might be some misses. So, if you attend classes, you will get those. Uh, it's not like willingly, I don't miss it for sure. Unknowingly, like today's class. So, coming back to you guys. How many of you are into software or data science role? No, software chhod do. We'll come to data science roles. So how many of you are in already in data science or ML? So yes or no in chat would be helpful. I open the chat. I can just check. Just type. No, 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 no. Not it, sir. Okay, very good. Not it, sir is a very positive stuff. I like that answer. Manish, that's the spirit you should have. Great. Yes. Okay. Few. Okay. Not very few. Huh? Aman is there. Nitendra is there. Not many of them. Okay. Don't worry. Priyanka. Priyanka is yes. So not to worry about this. I just wanted to understand how like mixed is the class. But actually, I cannot ask the other sections or too. I'll check that in the assignment. Thoda, I'm thinking of putting my brain in the assignments also. Don't worry, it will not be complicated. I just wanted to ensure, see, it's ethical, right? So when you're learning an course, learning a course, you wanted people to learn it. Sorry, when you are learning the course, I, as a faculty, want you to learn something out of this course, not just pass. I guess you will all pass or get some grade. That's what I have seen last time also. Until otherwise you miss major components like major exams or assignments. We can't help that. But if you have okay, if you are like into this sincere attending all classes you are attending or not doesn't matter. You are attending all the evaluation components like quiz, assignments, and major exam, mid exams. You will surely pass. There is no doubt in that. But I don't, okay, that is good, but I wanted to differentiate the students who learn something here. So what in the earlier time what we did, I'm not sure how I'm going to do that, but my intention, if you guys have some thoughts, let me know. My intention is, because you're all in varied levels, right? Somebody would be already in Gen A, somebody has never seen what's Gen A, right? So how I cannot, like, if I give a rack system, maybe a Gen A guy will build it in a half a day and give it. Maybe the other guy also will build it. I'm not saying that they'll not build it, but it will, that difference will be visible easily. But point I wanted to put it in the assignment is, today somebody is at level one. I wanted to test whether he has crossed, went to level two at the end of the assignment or not. So if somebody is today at level five, whether he has gone to level six or not. I don't know how to put it in the assignment. I'll ask my my chat GPTs and all, like chat Gemini. I have Gemini subscriptions. I'll use some intelligence. If you guys have some thoughts on that, how can we test somebody, a large number of people? I think around 500 people,
So
400 people, Manlo. Yeah,
yeah, so
I don't
so
want.
one yeah.
Yeah, yeah, yeah.
Can I speak? One thought could be have couple of options for assignment with the graded difficulty, and it will have weighted, of course. If a difficult assignment somebody does, maybe it will have carry additional weights, but that could be one way. So those who are new to NLP can take the easier ones. There could be 1 or 2 marks difference or on the weights, but at least people can do justice to their already what they know.
Yeah. But that can be like, just one small thing. I don't want to discuss this more. Just I wanted to say one thing, like even the level five guy will take a easier assignment, just to make sure he does it fast. So there is some criticalities. Like, let me see. Yeah, your point is good. I'll take it. So others, if you have any points on that, how we can check that. So it's not like, I'm not saying that, is somebody at level five, if it doesn't reach, like, if it doesn't, like, I don't know how to say, he has to learn, right? Something he has to learn. So at the end of this course, something should be there for him in his plate. Otherwise, it's not justified, either for him, nor the person, nor as a faculty for us, right? So that's what I wanted to see. Everybody has to go one step ahead, not just the same level after 6 months. If you're at the same position, then you have wasted your time and money, right, on this course. So I just wanted to ensure that. And of course, yeah, it's little bit, what do you say, compelling from the faculty point of view, but education is like that, right? We have to be, like, quite disciplined. Right? Somebody has to motivate us. That force only motivates us. I don't know whether you guys like this sentence or not, but that's how I also studied. So only because exams are coming, we study, right? 15 days before exams, we study. That's the truth. Yeah, Avanish. Avanish,
Yeah,
yes.
yeah. Hi, sir. So, sir,
Yeah.
I mean, uh, we have selected, I think, this course consciously. Matlab.
Mm-hmm.
So, that motivation is there. So, one request is that, I mean, we
Mm-hmm.
can start from the basics and we can go as far as like as you think like we can grasp,
Mm-hmm.
but don't limit. I mean, we want practical understanding of the real industry. I mean, that is my personal view. So
Mm-hmm.
that's you can. I mean, frame your lectures around that, please. I mean, given that there is variety of audience, but
Mm-hmm.
I would say like we aspire to reach the same level towards the
Yes.
end, and I mean, we are also committed to that.
Yeah, great. Yeah. Thanks. Thanks. You motivated me. Thank you so much for that. I'll ensure to take this point and consider this point and take it ahead. So one thing I wanted to, this is a practical point, based on my last four semesters. So this point, what you mentioned, right? So this is for today's class. I completely agree with the motivation I will have. But as it goes to the next classes, right? The next future classes, what happens is the people who are in the class only can direct me, right? So if they say that, sir, I don't understand this, please explain me, I have to spend time on that. So I may not be able to go far ahead, like what maybe for others, few of them, it might be very childish, right? You understand? So, of course, if you guys attend the class, I'm not compelling, but this goes like this. Of course, I don't have any other directions, right? So if somebody attends the class and tells that, sir, this is very, it is very like understandable, let's go a little more ahead. But I guess my syllabus is already taking care of all these things. I can give one guarantee: if you can grasp the course handout properly and all the topics in that, I think by the end of this 6 months, you will be able to crack some of the JNA interviews. As I already mentioned, right? So I have taken many of that from a lot of interview questions and answers. So it will be helpful for sure. So I'll see how far we can go. That's a point that good point you mentioned. But my practical limitation, what I said is this one, right? If somebody keeps on asking, I genuinely accept that. I cannot say no, no, I cannot explain you, right? That is also there. But the other thing is that I will not drag it. That promise I can give you. And I'll not ensure that I'll ensure that it's not like it's a simple topic and keep dragging so that I'll have less topics to cover. Okay, that promise I can give. Yeah, Manish, please.
Yeah, sir, one point I wanted to mention, I think most of us might be even facing, at least I'm facing. So in my company, right, currently, see with the last semester, so I know the fundamental and the basic, right? So now when I am trying to participate in my company with these kind of a discussions, okay, my teammates or even some of the experts are talking about MCP, RAG, agentic AI, right? So in last 1 year, so I have not done anything practical on that, or I have not installed and done anything. Okay. So one request is that more exercises, and so I understand that only two assignments you have, and not everyone wants to do all those exercises. But even though if you can share some of the real life challenges or others how it can be done, okay. So at least someone who was interested like me, we can try it out whenever we have time. Not assignment are there, but other things also that will help us to practically get trained and even discuss in detail, go into next level when there is any discussion with the customer or even internally in the organization.
Mhm. Yeah, yeah, good point. Yeah, that's valid point. Even I have thought about this point. Okay, we'll go through the course handout. We'll be a little more intuitive so that we'll not go around. Yeah, somebody, Mahesh, please.
Yeah, hi sir. Sir, I hadn't updated for a NLP in SEM 2, but looking at the course content and the buzz thing happening with the LLM, I chosen this.
Mhm.
So, do you suggest any prerequisite for me?
No, no, only deep learning is sufficient.
Okay, sir. Thank you
You
so
have done
much.
deep learning, right? That's a compulsory
Yeah,
subject,
yeah,
right?
I did it, sir.
So transformer should be sufficient. The rest of the things, if you didn't understand, right, let me know. So
Okay, sir.
little bit I have tried to make it more um, like I didn't wanted to make so many extra stuffs which I had earlier last semester. I removed all the things. This
Okay,
semester is very crisp and what is minimum required as the basics. Okay,
okay, sir.
yeah,
Thank
it
you.
should be sufficient. You will be able to grab everything. Okay, coming to this point. Okay, thing I was talking about is I have revamped everything. Okay, so one thing is that nothing else is required except mainly about the transformers. Okay, so this is I specifically mentioned. So transformers, of course, if you wanted to understand transformer, you should know neural network and ML models a little bit. Not required so much, but we will learn. But training, inference, evaluation, what does these words mean? That much you should know. Okay, that's why I've written basics here. And of course, Python is required. We'll do most of the things in Python, not in C++ or something. API basics, this is basic software engineering, right? How do you get the JSON data output, structured data, right? Nowadays, structured data is very important. Uh, Most of the models give that structured output. And these things, basic statistics, you would have already done. So I'm not worried about much about that. So we will be building some. I think at the end of the course, the last few lectures, we'll be building one basic AI system, because I don't want to make it so much complicated. But we will be discussing more about architectures. Once you know the architecture, a lot of chatbots are there, Gemini, Cloud, whatever ChatGPT is there, you can build it from there. Okay. Code is not a big deal, but you should know the concepts very clearly, and how do you architect it. That is very, very important. Okay. So my focus mainly would be about the architecture. What all should be there, why it should be there, how it should be there. This is very important. Okay. Building, as I mentioned, building is very easy. We will see some of the code blocks uh, broken into small pieces out there. If you really want to build a system, you can build it at the end of the course with all the code blocks, what you will get it from each of the lectures. That's your intelligence. Okay. And everything we'll see, all of these things, whatever it is written, prompt injection, sensitive data, we'll see this one. So there are four modules. I made it. It was not there earlier. So this was the major revamp of the modules what I've done. Earlier we didn't cover much of embeddings, so I have made sure this time embeddings is covered as a separate lecture. I think lecture 2 it is there. Then retrieval, which is the RAG part, and what are all the models which are available. How do you talk about cost? This is a very important thing, right? So as a manager or as a principal AI architect, I talk about this so much, right? Because it is the most important thing for the business, right? For a company, that is why we work, right? We build model to just get the profit, right? So how do you do that, right? What are all things we can, techniques we can use to reduce the models cost, and the system's overall cost, right? And build a very good system. And function calling, memory system, RAG pipelines, this is all we'll see in the second module. Third one is the planning, multi-agents, evaluation, optimization. The very important stuff is planning is one thing which it is very easy. Nowadays, every model itself is helping us to plan, not a much a thing to do it in your um, architecture. But multi-agent system, your architecture will be very important, because what you and me can do, multi-agent system can do far better than us. It's a very precise statement. It's not a like I didn't say it in a very like rough way. It's a really, you will see it. I'll show some codes wherein you can't even think how it can build, right? Why I say this is, you may say that okay, no, humans are better at it. No, I disagree with that. If you start building multi-agent system, you'll understand multi-agent system. And one more thing to give more confidence on this point is that multi-agent system is not just LLM calls. Okay, it has lot of other things around it. So that is what you have to build. It's not just calling a chat GPT and asking what is it, and then it gives some partially correct answer, and we laugh at it. No, that's a very childish stuff, and anybody would, even a 12th standard student will tell that, right? So what we are going to build is a multi-agent system and completely agentic in nature. Okay, so and how do we evaluate? That's very, very important, because that's how you build the confidence for your customers or whomever you want to give, even if it is an internal customer. Optimization, of course, that's part of the cost engineering. That's here. Third one is, this is like mostly spoken nowadays. If in this GNA field, MCP and A2A, we'll see MCP. We already last semester itself I covered. A2A I'll cover this time with code. I'll cover both, but the A2A this time ATA I covered last semester, but I didn't give code. But this time we'll give with code. Okay. And ethics and governance is most important. Governance review of any system before it goes into production is the apt one, right? So these are all some of the things you can go through. It's not required. If you follow the slides, it should be sufficient. So if you see the modules, it's very interesting. Okay. So foundation, today's class will be just a walkthrough of what is conversation here and other things. It will be very easy. And next semester, next class onwards, it will be very bit complicated. I don't know. Those who are already working on GenAI will be very easy, but it will be. This is very very important. Many of the people I have worked in two companies. I have interacted with many people. GenAI, the so-called experts out there in the market, because even for bits there are a lot of people in your student batch also. They come for projects. I know I have interacted with people who are working in Microsoft, Google, and many companies. They do not know the basics of this, like embedding, vector search, hybrid. They started building agentic framework. I really wonder, because it's very easy to build, right? It's very easy to build, but when you start evaluating it and then trying to optimize the system, there you need all these things. If you do not know this, you cannot. You can easily, today I'm saying you, I can show you in maybe 1 hour. I can build a agentic system, multi-agent system. Why this 6 months course, right? As simple as that, 6 months or 4 months. Why? Because of this evaluation. When you evaluate, you will understand that, like for example, 2 years before, when we first built a chatbot, it was giving only 50% accuracy. Not even 50, 40 to 50. 2 years before, that time we didn't even have a structured output of from the models. Okay, 40 to 50 percentage. But today we can get around 80% accuracy or precision. We'll see all those things. In layman's language, it is accuracy. Okay, so 80% accuracy. Why? How? In meeting that, from increasing 50 to 80, it requires lot of knowledge. After you evaluate it and identify where it is failing and how you can fine tune your agentic system. You will not, it is simply not applying some techniques and it will come. Applying some techniques, yes, of course it will come. What will come again? 50% will come. Maybe 40 will become 45 or 50 will become 55. To reach 80, you need this. Okay. You have to very clearly understand the second lecture, this lecture, and this lecture also. Okay. And memory is for multi-agent. If you're not using multi-agent, even for LLM workflows, this will help. Short-term memory, long-term memory. Okay. And this part is, of course, this is the basic stuff. That's what, if you go to market, not even market, you go to GitHub while you're here, before the end of the class, you can build a rack pipeline. That doesn't justify even an MTech project. Nowadays, if I am a project evaluator also for the MTech, if you see the MTech project guys, if they come with a RAG pipeline, I'll simply reject it. Because if you are intelligent enough and if you are in laptop, I can currently open a GitHub, pull a code, run it in my laptop, and RAG will work. It's just half an hour work, and project work is 16 weeks. I guess 16 weeks, yeah. Even 16 weeks showed, though you don't need to work 16 weeks. Consider, okay, 2 3 weeks for report preparation for both the mid exam and final exam. 10 weeks of work. What I'm talking, RAG system you can build in 2 hours, and they come up with this kind of project at the final semester. This one, so it is not justified, right? So that is what I tell them. They may accept or not. That's the truth. So either they do not use it, know to browse through internet. That's the one thing. They are very ignorant of the world, right? But when you are studying this course, you should be, that is not justified, right? You have to learn how things work. So if somebody else in your batch can build it in 2 hours, maybe you will take 1 day, but 1 day is still not justified. So next, after mid exam, we'll concentrate more into agents. Okay. Till here, it is individual parts, right? All of LLMs and small parts of LLM. So after this one, we'll talk about agents, and here itself we'll talk agents. Lecture 9. That's after mid second. Okay. So I given L8. I normally don't. We cannot simply give a break for L8. So I combined L8 lecture 8 to lecture 7, so that lecture 8 will be for only for revision. So you will not have any much of tension in the last class. Okay, before mid exam. So then we'll start with agents, and then we'll go into evaluation, cost optimization, security. This is very important. Governance, right? Security is one part. Governance, I made it in the other one, so that we'll go in little bit detail. Okay? And MCP, as I mentioned last semester, I combined the MCP and A2A in single class lecture. I broken down that into two parts. We'll see some code also. Okay. So we'll see how to build it, how to build this architecture. Okay. This is not building. This is okay building, but this is not building. This is just an architectural pattern. Okay. So, but that is very useful for some cases. We'll discuss that. Okay. So it's not for all cases. A2A is not always useful, but in some cases it is useful. And if we have more time, we can think of. Surely it will not be, but I can say it AGUI, and there is NL Web by IBM, I guess. Those two are also protocols. We can think of it. Okay. So maybe if this is very easy, or maybe this will be very easy, because this is once you understand this MCP, A2A might be very easy. Okay. So then we can add that here in case possible. Okay. If you guys want later. And coming to the evaluation, so normally two quizzes, right? No three quizzes, and don't come late, right? Some guys they miss out due to some reasons, and then come back and say that, okay, sir, please open the quiz. So okay, I can open, but if I open, I'm a very soft-hearted person. I open it, but don't make try to, because we are also having a lot of work, right? I'm also in job, right? Like you guys, weekend is only free for me. Keep pinging me in between. And there's I can miss it out. Then I will feel guilty that because of me somebody has lost mark. Okay, so I want everybody to pass. That's the point, and everybody to learn. It's as simple as that. My logic is simple. Everybody to pass, everybody to learn, and justifying my faculty position, I have to find a differentiation between who learned more. Right? That's the simple three sentences of what I can talk about my work here. Okay. So and assignments 1 and 2, as I already mentioned, how I wanted to frame it. It will not be same as the earlier one, because people. um I tried last time also in a good way, but yeah, I think I did justify last time. But this time I wanted to make it a little more intelligent. Let's see how it goes, or otherwise I'll follow the last logic only. Okay. Anyway, default logic is there already, and open book will be the last one. It will be more of, you can see. I'll share the question paper. It will be almost same as that, because the topics last time itself we had MCP A2 and all, so it will be almost a similar kind of question paper, but it will be like you have to think, right? You have to think and identify what is uh, which technique you have to apply for a particular scenario. It's simple, right? So only thing is, if you understand each and every technique here, you will know, okay, if this is the issue, you will get what technique you will use, right? That's very easy. And why I say this is, exactly that is what I asked for a senior data scientist or senior GenA engineer whom I will recruit. So if you know, if you can get very good score here correctly, you are already, you can go for interviews. That's what I understand. At least 50% you can cover, because they will ask production questions also. In fact, I asked. So those questions you may not be able to answer only based on this course. Okay. So hope that is good enough for today. Course handout, I guess everybody understood, right? So this is what I've just a quick point. anybody has any anybody has any thing in mind which I have not covered here? Do you think I've ensured everybody?
So Bharat, this is Anwar here. Just quickly one thing. So this syllabus is uh, what I can see is that have you customized it or it is across all the sections the same?
I didn't get you. Customized
So
it means?
so when you say you've added MCP and A2A, this is the same for all the sections, right?
Yeah. This
Okay,
I'm
okay.
the lead instructor.
Okay, okay.
This
Okay.
course handout I have to give it to other faculty. They will just deliver it there, right?
Okay, okay.
So nobody will change this.
Yeah, yeah. No, no.
Okay.
So in the last semester, there was a professor who did teach in a very different way. So that's what I thought.
Okay. Okay. I think Vijay. Yeah.
Anwar,
Okay.
Anwar.
Anwar. No. Not your name. I'm talking about the professor's name.
Okay. Sorry.
Do you know his name?
No, no. So
Who's the
not this
professor?
topic. It was on NLP.
Okay.
Uh,
Okay.
yeah.
No.
So his approach was
That.
totally different, even though he was following syllabus, but then he was
Mm-hmm.
approach was totally practical, like the way you explained.
Okay. Okay.
Yeah.
I don't know. See, the syllabus will be same. The slides will be prepared by me. Okay.
Okay. Okay.
I
Yeah.
will prepare, but point is the delivery will be done by individual faculties.
Got it. Got it.
So
Got
it
it.
depends on their style, right? So style will
Sure.
be, of course, different for each of them. Okay.
Absolutely.
So,
Yeah.
but the slides will be the common slides. I will only put it in the canvas.
Yeah.
But individually, they will share their own writing slides to each of their sections. Right?
Okay. Got it. Thank you.
Yeah. Okay. These are all empty slides. I kept it for writing later. Okay, we'll come back to this here. Okay, coming to the motivation, it's a very childish stuff, but I just wanted to say you guys might be already knowing this. That's why you have taken the course. Just to give I got this today only. That's why I wanted to share. You can see the date, right? So it is 2025 to 2034, right? Ideally, I got it today only. It's there in the internet. I think market.us US. This website, it is there. It's a full report. I don't have access. This was just only the preliminary part. So you can see how the growth is like. Right? So you see today what's the growth, and till 2034 what is the growth. So it's a huge amount of growth is possible in this market, and so learning this course also will be helpful because you can become a conversational. Even I have seen one job like that when I was searching job also. It was like conversational A engineer. That is Exxon Mobil or some company. Okay, so that was a good thing. So, or otherwise, Gen A. Normally, people call it a Gen A or data scientist till now. It's a very general word, but mostly people work on this conversational AI systems only. Okay, and virtual agents. You can go through all these things. So these two things are what we are going to concentrate. Okay, and okay, coming to this. Okay. Tell me, okay, I will only tell. This image is generated by, I think, Gemini. I generated it last week only. It's very easy. Just give the this content, and then tell it to generate. So it was very interesting, right? So how the agents are talking to interacting with the humans. I wanted an image of this. So how easily it is able to understand my conversation. So my English is not so good. I don't write it in a very well framed English sentences, right? So I just told the Gemini, like I wrote it to Gemini in text form only. I told it to create an image uh, to so that agents talk to humans in a natural language. I think natural language, it took it as a natural landscape also, the back end. So it was good. Okay, it's a very evolved uh, stage. So you can never find this image anywhere else. I hope so, because I generated it from the Gemini and I ensured that it's not available till date. But that was also part of the prompt, right? So I think once, twice I had to revise the prompt second time because first time there were it was not satisfying. But it is good, right? So main point is that conversation it is natural and human like ways. This is the most difficult part. What I wanted to say here is natural and human like ways. The way I was explaining now, that my English is not so very well framed, right? But still it could understand, right? That's how we speak, right? So I speak to you in a way, it is not so professionally very, it's not worth a speech, right? It's just a casual discussion. So that is what we expected from our conversational AI systems. That is the most difficult thing here. Okay. And how we are getting it, we require LLMs because it was not possible to talk like this or text to systems, conversational AI systems like this prior to LLMs because the earlier systems were more of NL rule based or deep learning based, right? More advanced is a deep learning or ML based, what we call ML based chatbots. Even those could not understand our broken English words, right? Because as I said, I worked with two US companies. Their people there, they type very fast, very a lot of broken words will be there even in their language, right? The way they speak. So they wanted to, but our chatbots could easily, like it is very easily understanding their language. That's the first step. That's called intent recognition, right? That's the first step of a conversational AI system. You have to understand what they're trying to say and whether it is related to the previous sentence what they spoke, right? Previous query what they spoke, or previous sentence what they spoke, or it's a completely a new topic, and whether I have to go and refer something else for answering this query, or I can myself answer this query. So this is a very basic intent recognition, what I mentioned. The three steps, right? One is to identify whether the user requires me to understand this sentence in line with the previous sentences, or it is a completely a different topic. That is the first intent. Second intent is whether I have to go and refer a tool and come, right? Tool means whether I have to go and refer, like for example, I ask you a question, like you ask me a question, I do not know the answer, right? So I refer internet, or I refer a book, or I ask a chatbot, right? So whether I have to, so I should be intelligent enough whether to understand what you are asking and then check whether I have to refer something or not. Right? That's the second thing. Third thing is whether I can myself answer. If I can myself answer, then I should have a lot of memory myself, like inside me, right? So I should, like humans. So how can a model have a lot of memory? That's what we'll see. That I think you would have learned it in your transformers also. But you understand that all those neurons, whatever you're seeing, everything is there, right? All those hold some numbers, and the numbers are the tokens, right? Or tokens means words. That's how it remembers. It's a very complicated, non-linear function. What is the neural network? It's a complicated, non-linear function. Simple, right? Nothing more than that, and it holds a lot of memory inside. So all these things we will learn one by one. So core capabilities you can understand, right? NLU understanding. This is what I was talking about till now. The intent recognition, right? The intent is the most important thing. If you make a mistake in intent, but after that you cannot go. It's like the first step. You take a wrong route, you're lost into the forest, right? Something like that. So, and the dialogue management is the further one. So, what I was talking about in our course handout also. So, how do you manage the conversation? So you should have a short-term memory, long-term memory. Long-term memory is like what I told you yesterday or the previous class. That's long-term memory. Short-term memory is what I told today, like the previous conversation till now, from the start of the class till now. That's short-term memory. So how do you manage that? So as you go, like 10th turn, turn means it is like 10th query, right? So I ask a query, you answer. I ask second query, you answer. So it's like 4 turns like this, right? So that's what we call it as turns, multi-turn interaction, right? So for as we go like 10th turn, 20th turns, so it becomes more complex. Like the short-term memory also too much. Like at the end of the class, I would have spoken at least 100 sentences, maybe 200 sentences, right? And and if I ask you a question, like, okay, what did I talk about the course handout? So as a human, you should remember everything what I spoke from starting to end, but you will try to remember what I spoke about course handout maybe between 10th and 25th minute of this class, right? So I have to go, you have to go and find that memory in your brain and then bring it and then answer me, right? How will you make the model to do this? Find the correct relevant information in your past interactions and bring it to your current context to your LLM and then give the answer for the query asked by the user. That's almost like a very simplest way I can explain dialogue management. We'll go more deep. Okay. So finally, natural language generation, right? So generation more like humans, right? That's if you can do this good, it will also do this good. Okay. And generation, it can be images also, it can be audio also, like speech, right? And it can be a text also in general. And personalization is the most important thing, and this is one of the things which we did last, not last, after some 1 year of the chatbot into production, right? So it is like we have to have this personalization in a way that each user feels that they are talking to somebody, some chatbot which knows him better, right? So every time you ask a question and the chatbot again goes into the rack system and brings an answer to you, it looks like a really a computer, right? But if it can speak, hi Bhagat, like I can show you Copilot what we have built. So it will talk about like even the first initial questions just before I start typing the first query which I have for today. It will give an points, like it'll give some questions which will talk about what I spoke yesterday, right? That's one thing. Second thing is when I ask a query, it will refer to my like for example, if in a general case I'll tell, not in domain specific. In general case, suppose you consider yesterday I uploaded my resume to my chatbot, okay, and then I asked few questions, right? And today I say that okay, um, uh, what will I plan for my birthday? Right? For example, I ask a question like this to my chatbot. It will tell me, our chatbot will tell me that, okay, your birthday is coming the next week. It knows my date. Okay, because I uploaded resume yesterday or last week, that is the long term memory. It goes into the long term memory with that thing, the required information, the major things, and then stores it. Okay, and then it brings out. So I just ask, what can I plan for my birthday? It will say, okay, your birthday is coming next week, this date. That's nice that you're asking this question. Let me think of a plan for you. Okay, and then it gives me the plan. That's the personalization. That's the amount of personalization we want. So mainly for this dialogue management and personalization, more of memory management is very important. That's what we call in today's like era. We call it as context engineering. Okay, so we learn about that more. Okay, context awareness and context engineering. Okay, so these three parts, this one, and this one, is very very important. And any company you go, any GenAI interviews you go, they will ask about context engineering. Earlier, last year, if you would have asked me, I taught people about prompt engineering. It's like prompt engineers were there, but nowadays it's context engineering. So prompt engineering is just giving an instruction to an LLM. Okay, you tell me this, you tell me that. But context engineering is beyond that. It's like prompt engineering. I'm telling, okay, you do this, plus you have to give a knowledge of my previous interactions. That is the long term memory. What I was talking about. Long term memory means the interactions what I had with this same chatbot yesterday, day before yesterday, last week, all those things, and everything you cannot feed, right? Every LLM has a context window. So I'll talk about that context window a little bit. So this evaluation journey you can go about. Okay, this is not a big deal. Just the last things I'll go. So here 2020 to 23 we had LLMs, all these things. Okay, so in 23 to 25, not exactly 23, 24 to 25 we have agentic AI. So 23 also we had, but not so much famous. We started even that time. In fact, when I came to know about agentic AI term, I was literally shocked because we were already using that in our chatbot without even knowing that that is agentic AI. Okay, it was like that. So we were already having tools, but the only point was the LLMs were not so capable of giving a structured output. Structured output means, so when I ask a point, like, so for example, okay, what is the score? Okay, for example, score, something like this. Okay, no, not score. I will say, what is my date of birth? Okay, so you can say, what is my date of birth? LLM will, earlier LLMs used to give us like my date of birth is um, so and so date in October. Okay, but today's LLM can give it in a as a JSON format. That's the beauty of today's LLM. Okay, not today's, like 24 half onwards it is coming. Like it'll give you in the JSON format the date of birth and then give you the date of birth exactly in the format what you ask for. Okay, so it'll be like this in exactly in the format what you asked for. Okay. Date and month and year. So it's like Indian style. So exactly in this format it can give. That is the major requirement to make it agentic. And not agentic. Agentic means ideally to call tools, right? So if I have to say, okay, I have tool one, tool two, tool three in my uh, my LLM has access to tool one, tool two, tool three, for example. Okay. So if I say, okay, for the given question, so now I am asking, okay, I wanted to operate on tool two. Okay. So LLM is a next word prediction model, right? So it will write as a uh, sentence, right? It's a sentence. It's a text, not sentence. It's a text. So earlier models used to say, okay, for this query, please go and access tool 2. Okay. So if you give such a sentence, programmatically, I cannot read from that sentence, such a big sentence, right? So from that sentence, I cannot understand that, okay, tool 2, I have to go. Sometimes it will say, okay, for this sentence, you have to use T2. Sometimes it will say tool underscore two or something like that. It'll every time it will keep changing. So programmatically, I cannot take that into production, right? To because in production, I cannot every time go and read, right, as a human. So you have to make it automated. But today's LLM can give very perfectly in a structured format. Okay, the tool to be used is two. Very perfect, right? This is a JSON format output LLMs can give. So this output, if you give, and just you can read this, okay, tool is equal to 2. So I have to route my LLM to tool 2 to operate. So this was the major requirement for this part. And this part solved many things. And that's what is the most, that's how it got so much boom. Okay. So in fact, many LLMs nowadays, most of the big LLMs, even small LLMs can do this very nicely. So all this complex stuff and scaling, mainly production, you cannot go into production without this part, this one what I mentioned, the structured output. Okay, that's the most important thing, which is not mentioned in many places, which I want to. Okay, And this is what I said, right? So rule based, you understand. Rule based is just you. If this is the case, you reply with this. Okay, this is like if else statement type. Okay, this is very old stuff. Next one is the statistical. These things you can go through. Okay, my screen is so big. I have to go a little away. So these things you can go through. Okay, this evolution is not a big deal. We'll understand what is currently there. Okay, so this one is important. So if you would have, how many of you have worked on any of these four in the chat? Have anyone worked on these four? No, nobody. No problem. Okay, so this is the old style. So old style, not I'll not say old style. They have also upgraded themselves. Okay, they have also upgraded, but these are all specific to particular platforms, right? And these are very good models. They started when the rule-based chatbots were there. These are all chatbot frameworks. Okay? So they have frameworks or architecture you can talk. Help. These were all very good with. They had the what do you call the rule-based chatbot. Then they evolved to deep learning stuff. Okay. Currently, each of them have implemented the LLM-based workflows also inside that. So, but what I wanted, why I wanted to come to this slide itself is, we are not going to concentrate on any of these four, but we are going to concentrate on something what we can ourselves develop these platforms. So if you know to develop these, you can go and use these four also. Not a big deal. You can go and use these four, but see, it's not very easy to just plug and play. So Raza, if you use, it's not like just plug and play. You have to customize it, right? So you have to give the correct feed, correct context engineering. So for all those things, you actually need the modern architecture understanding. Okay. So that's why I say, because many of the students last time they were asking about these, but we are not concentrating on this because what we learn here will be inside this. Okay, maybe one or two here and there extras will be there. I'll check what extras might be there in this, but everything what we hear, what we learn in this modern agentic architecture will be sufficient. You can build your own custom architecture which can do all these things. Okay, and also if you wanted to use these models, yes, you can go and you do. And once you wanted to improve their efficiency, you have to know the knowledge of these things. So here you can read all these things. Okay, this one big things. Okay, so again the same thing. Started with rule based, then intent based. Intent based is, you understand, right? So we use ML or deep learning to understand the intent. So if I think last class we had, it's just a deep learning network. Once you give a particular sentence, right? So a user who gives a query, it will give you the intent based on, but it can only predict. The intent based system can only predict what it was trained for. That's the problem with that. That's the limitation with that. Okay. But nowadays, LLMs are very intelligent. Even if your sentences are so horrible, like the way I speak or how you, like we casually speak with friends, right? So you speak, and in fact, the most beautiful thing is some of the LLMs are like you can speak half in Hindi, half in English, still it will understand the intent. Okay, that is impossible here, ideally impossible according to me, until you have two DL based systems to understand that. LLMs can understand it very nicely. It's like, for example, GPT-4, I think it understands 50 languages. And it's not like you have to speak either in Hindi or English. No, you can speak English and Hindi, half broken like the way we speak, and it will understand and give you the intent, which is impossible in the earlier DL based. Okay. And agentic one, as I mentioned. So everything what the LLM can do, the natural conversation. So that's what the best example to give the natural conversation example is what I said. So I speak half Hindi and half English, still it is able to understand. a context understanding, right? The context it will understand and get you the perfect response also. So agentic one, everything above. Okay. Apart from that, accessing the tools. So it's written as banking system for this particular example because it's banking customer care. Mainly accessing the tools, and you can make a multi-step. So you can have a like. So once you call LLM, so chat GPTs are not just GPTs, right? So I hope you guys know that much. So GPT-4 is not chat GPT. GPT-4 or currently it is 5. The latest one is 5. And they have 5 Pro also. So GPT-5 is the model. Okay, this is the LLM. Some of them will be always confused. And Chat GPT is a system. Chat GPT. Okay, it is a system wherein GPT-5 will be one component. Okay, it's very important. Chat GPT is a complete flow. Okay, complete flow means it will take the user query. Okay, this is the query. It takes the query. It may have a small SLM. Okay, small SLM to understand the intent. Okay, to understand. Okay, I'll make it big. Okay, to understand the intent, and then it will, based on the intent, it will go through different pipelines. Okay, so whether you ask for a summary, you ask for this one, all this. Okay, then it may again can understand like one more small SLM or LLM, or maybe you can say GPT-4. So here GPT-5 will be there. So it will try to understand, like if it will try. Now if the SLM says okay, the intent is to generate an answer. For example, the another intent what I wanted to say is like, okay, I said hi. So for hi, do you think you need GPT-5 to reply your hi? No, right? For hi, OpenAI will not use GPT-5 to reply. They will have another one small SLM, or this same SLM will just reply hello. It will not even send it to GPT-5. Okay, so if you say hi, hello, it is a very small model. Even 300 million parameter model can reply this hello. Okay, so why do you have to waste such a big model for this hi, right? And it will take for time also, right? So this is what is very important to understand for intent prediction. Okay, so intent classification, it's not prediction, classification. You have to identify what is the intent. There may be many intents in your company. It's not just one, right? One is this one is high, right? So another one is the something like I say stupid. Okay, something like this. Just sorry to use wrong words in the professional scenario, but stupid is, suppose if the user says stupid. So do you think SLM will even, SLM has to understand, maybe there is, I don't know, which nobody knows what is there inside ChatGPT, right? So I will give one more example. This is a query. So I will say the query is parallelly sent to another SLM. SLM means I don't know whether I hope you know, it is small language model. LLMs का छोटा बच्चा है, ठीक है? So it's like small SLM. So you call this as SLM2 and this SLM. So I'm not sure this is how ChatGPT works, but I can, if you want me to build, I can build it like this. Okay. So it is just a simple basic stuff. Actually, it is very complex. Okay. So it will take 3 days for me to develop it. So just that I'm giving for an example. For example, here I say first time hi. Okay. So it goes into this and it goes into this. This produces the answer as hello. So what is this second SLM is what I'm calling it as a what do you say, guardrail. What is guardrail? Guardrail is something like understanding whether it is secure or it doesn't. It understands whether it is a maybe the query is not acceptable, right? So like for example, I was talking about stupid, right? So stupid, again, this stupid word will go into this LLM and this LLM parallelly. Okay. So this will try to produce the answer, but before that, we will check with this SLM also. Okay. So the stupid goes here. The SLM will understand that this is not acceptable query. Okay. So ideally, this will both has to be combined. So hi also will not go from here. So both has to be combined, okay, and then the reply has to go. So for hello also, hi will go here, and this SLM would have told, okay, it is acceptable query, so you can answer. So that combination you will do here and then reply. Okay. Same way, when the stupid goes, SLM will produce the answer. This SLM2 will say that no, this is not a correct query. This answer, the whatever this SLM answer, whatever it is, should not go, right? It should be very compassionate. So you should be able to give a very apt professional reply to this. Okay. So that is how you can also design. These are all small, very small tweaks I was talking about. Only when this says okay, this and this LLM says that okay, it is okay to go ahead, okay, and this LLM could not answer. Okay, 2 points. This SLM1 could not answer, and this SLM says that okay, it is okay to answer. Then only it will send it to your that GPT-5. Okay, this is a very simple model. Okay, so now this will send the reply. Okay, so if at this point you say that okay, this for this small query this SLM only can answer, but for a big query like I'm asking what happened in India in 2023, so that's a big question, right? So SLMs does not have so much memory; it will not be able to answer such a big question. So it says that okay, I'll not be able to answer, and this says that okay, it is an acceptable query. So that will be combined here, and then it will be sent to GBD5, and GBD5 will produce this bigger answer about whatever it is. It talks about 2023 how was India. Okay, so it's a small thing I wanted to say. So this is a very small thing, but agentic AI architecture will be more complex than this. Okay, I have not included any tools and stuff there. Okay. Components. Okay, this is what we have already discussed. We'll go through fast. What's the time? We have one more hour. Hmm. Hope you guys don't require a break. You? No, right?
5 minutes.
Ah, 5 minutes. It's very costly. You can take a break. Maybe watch my recordings later. Okay, take 2 minutes. It's
Okay.
4:59. Take 2 minutes. Huh? Sorry, huh? I'll be late. Actually, we have code
No
also.
problem. No problem. Yeah.
Hmm?
Sure.
So, anybody else have any general questions? Which may you can tell me anything. Okay, there is a question here. Just before that, I'll check the chat. So, how does SLM know the query should be handled by LLM? You will feed the SLM, right? So, SLM will not know about LLM, but SLM will know about itself, right? It's like, for example, you come to, for example, you ask your friend, right? You ask your friend, "Arey bhai, ye batao." Oh, sorry. You tell me about this. Okay. So your friend says, "Oh, I do not know about this. Let us ask the professor." Something like that. Got me, right? So if your friend knows what he knows, whatever is beyond him is going to be somebody else who knows better than him, right? That's one thing. But that's not very as simple as that. There is one more logic that even if that SLM thinks that okay he knows, there will be a validator before the reply comes to user. Okay, so in this I didn't add. That's why I said this is a very basic framework. This is not a complete stuff. So it's not like that. This SLM says okay, I know to answer a particular question, and the exactly the answer goes out. No, there will be a validator at this point. Okay, so that validator, there will be two validators here ideally. This SLM, what I called as guardrail, is called as input guardrail. Okay, I don't want to go in depth. That's why I didn't say all those things. Here also you consider there is SLM1 and SLM2. Okay, I'll say 3 and 4. Okay, for now. So SLM3 will be the validator. Okay, so re-verify. If it says okay, SLM1 over exaggerated too much and did a over smart works by saying that it knows the answer, uh, If it validates correctly, it will send the output. If it not, then it will send it to GPT-4 file. Okay. And SLM4 is the output guardrail. Output guardrail means whatever SLM1 generated. See, SLM2 checked whether the query is an acceptable one or not. SLM4 is going to verify whether the answer generated by SLM1 is a acceptable, valid, based on a particular region. Like for example, in India, you launch ChatGPT. You leave ChatGPT, you say some chatbot. Okay, chatbot. You launch it to Indian people. This output guardrail will be different, right? Ideally it cannot be same as for Indians and anybody else. It will be based on the ethics. That is called it is very very important. So this SLM4 will ensure that it's professional, it's ethical, it's acceptable for that region, right? So every place this might be different. So that's why GPT-5 might be same for every country, but even GPT-5's reply will be reviewed by somebody. Maybe it is also one more LLM. I say it as SLM. Maybe it is a bigger LLM, not like GPT-5. It may be another bigger LLM, like 100 billion model, right? Something like that. So it will evaluate whether that answer is acceptable for the user, for the professional language, or acceptable for that country, like that. Okay. So in our companies, because when we launch our chatbots to different customers, we'll ensure based on their country rules. So this guardrail, output guardrail, ensures that. Okay. So one funny example I will tell. Okay, we have already crossed 4 minutes. Okay, that we will see when our guardrails wala lecture will come. Okay. Okay. I hope I answered that question. Oh, thanks for confirming. I hope I answered that question, right? How does yes? Yeah, Manish. Yeah, tell me first.
Yeah, I think he partially answered my question. So the validator and SLM, sir. So these will be on the edge, and the GPT will be on the data center. How it will be like? Because it will
It
be mainly
depends
will be
on.
immediately accessed, right? Yeah.
Yeah, it mostly like Gemini has done that. So it again depends on your use case, right? So like in our use case, we have deployed it in Edge. Only the output guardrail, not the input guardrail. Input guardrail is still with us in the cloud only. Okay, but it depends. Like for example, I read recently Gemini in your mobile itself they have a edge model for smaller queries, like you say hi, it will immediately say hello because it's the model is in your mobile itself, right? To make it fast you can deploy, but how well is that model, right? So how good is that model? And it should be 100% sure, okay, whether whatever it says is a valid and acceptable. If one more thing also I want to say, it's not always mandatory that you should have SLM1 and SLM2. Even one SLM can, if it can do both the jobs together, that's also sufficient. Okay, it's not mandatory that you should have two different SLMs. Okay, okay. I hope I answered your question also. Hmm. What I was talking. Okay, frameworks. Okay, frameworks. We are seeing these four frameworks. There are some more frameworks I have not included. Uh, there is one more good framework I'll tell you, which is semantic kernel and autogen. They have combined. Even Microsoft has combined both the frameworks and made, I think, agentic framework, agent framework, Microsoft agent framework. That is the latest framework. I didn't update this, but that was released last month. Okay, but I I took it like this. But mainly we can use LangChain, but it's not mandatory. But say why I say it's not mandatory is learn to do it from custom code, Python code, because in LangChain everything they'll give you like cooked food. So if you want to learn cooking, you should learn to cook from uh, raw materials, right? You should not cook it from a ready-made fast fast food type, like what do you say, ready-made type of food, right? Chapati will be ready-made, something like that. A dal ready-made fast food type material. You should not cook like. So LangChain is something, it is good, you can use, but why we prefer to use, I will tell you my personal experience why we have to do custom is, when you go for production, that is more useful. LangChain, I will not say no. You can try it. We have deployed one in production also, but we have to monitor it. Like we are monitoring, it's recently done, but it's we trust the custom code because custom Python code works very good. Only calling LLM, you can use some. If you are using OpenAI's GPT, you can use Gemini. You can use their GenAI. I think GenAI is there. Just for calling that, you can use that framework, but you don't need to use agent frameworks. Right? Agent frameworks are these. If you want, you can use, but there are simpler libraries. These are all heavy libraries. Okay, heavy libraries which may not be so completely useful for you, and in production it may or may not be useful. So it's if you are going to use this in production, you have to test it in production carefully. Uh, you have a lot of tests, right? We'll see all those tests. In production, you have to do the test. But if you are using custom code, you can test it in your dev and then launch it in production. Okay, no need to worry about production. But these things in production, whether it is useful, working correctly or not, you have to check. That's one point. Other than that, you can just go through. Oh, one thing I told, these two merged and then made us Microsoft Agent Framework. Other than that, these are all there. And Hugging Face is also there. There is one more. Haystack is from Hugging Face, I guess, right? If I'm not wrong. Other than there is some other Agno. Agno is also one framework you can use. But to be a very good GenAI engineer, use custom code. Okay. For quick POCs, okay. Quick POCs, these are all fine. Okay, but when you are coming for interviews, I will not ask all this. Not me. I think good managers don't ask these frameworks. They ask concepts. Okay. Okay, these things we already discussed. The modules 1 to core building, and module 3, module 4 is done. Okay, this is very important. Just now only we have come to the syllabus about technical part. Tokens. So what we see is words, right? As a user, we see words. Like when I ask why it matters for conversationally to the chatbot, it doesn't understand this way. It may understand like this one, this side. It's very easy for me to understand. Hmm. Okay. Okay, I guess you guys can see this. This is from OpenAI itself. So how does their tokenizer divide? Okay, so we can see that. Okay, let me see. Take that word from there. I'll type in here some. I will only type on. What is okay? This thing, this is between me, and Delhi. Okay. So you see, this is my query, right? I'll just zoom it. So this is my query. We'll start with the GPT-3. This is a very old model. You see how it has broken. So if you see, actually, we had 1, 2, 3, 4, 5, 6, 7, 8. 8 words are there, right? But it has broken into 11 tokens. So what is this tokens is? Tokens is what how it understands a model, any model. So here this is GPT-3. GPT-3 is the model. Okay, GPT-3 understands this Bengaluru as Bengal, space Bengal, and Uru. Okay, it doesn't understand Bengaluru. Okay, and same way, Delhi also it doesn't understand. It understands space del and high. Why this happens, we'll explain. We'll see. This is the vocabulary. Like for example, if you are teaching to a kid, right? So if you have never taught a kid about Bengaluru word, okay, so it will not grasp it completely, right? So, but you have taught space Bengal and Uru, okay. So it will also learn like this. Bengal is one word for it. Uru is another word. So forget about your English. Okay, your English is like you want a gap between two words, but for computer or for the model, the space does not mean anything. It's just another character. It's same as B, and the space is same as B for it. Okay, so space between is one word for it. That's what we call it as token. Token is specific to a model. Okay, so token vocabulary, not token. Token vocabulary is a specific to a model. So every model, if I go to GPT-4, okay, so now you see GPT-4o is more later model than GPT-3. Okay, so now you see only 10 tokens. How Bengaluru has become complete word. So GPT-4o knows complete space Bengaluru as one word. Okay, but GPT-3 did not know. Why? Because uh, one reason is the words which we have trained, okay, the words they were like the training data to the GPT-3 model did not have Bengaluru as lot number of words. Okay, maybe one word it one time it would have had in that complete uh, training data. Training data will be like 1,000 books. Okay, in the 1,000 books, not 1,000, it's like more than 1,000 books you can say. So for us, like currently you consider 1,000 books. In the 1,000 books, Bengaluru would have been mentioned just but only once. Okay, it's a very less important. So the GPT-3 never learnt that model, but in GPT-4 the model is also big, and they would have trained it with 10,000 books. So in 10,000 books, Bengaluru would have come many times. Okay, and also the number of tokens learned by GPT-4 is also big, because the model is big, so more words it can learn. So it would have also learned space Bengal. Okay, the GPT-4o would have also learned space Bengal. Also, it knows space Bangalore. Means it knows Bengal also, it knows Bengaluru also. But GPT-3 does not know Bengaluru, but it knows only Bengal. Okay, understood. So it is like more you learn, more words you know, right? So because the bigger the model, the bigger more number of words it knows. GPT-3, I guess it knows about 50,000 tokens. So it knows only 50,000 tokens, but like we'll see examples. Okay. So it knows only 50,000 tokens. But if you say GPT-4o, it will have like maybe more than a million. For sure, more than a million. Maybe it knows more than 10 million words. Okay, tokens. How do we create the tokens? That's what we will see in the code. Before that, we'll see the rest of the slides also. So now I hope you understood. Okay, it's like a memory. It's like more words you know, more things you can. Like for example, a kid would have learned what is break. Okay, but as he learns more when he goes into fifth standard, sixth standard, they'll be able to learn what is breaking, right? What is breakup, something like that. Lot of things, right? So a lot of words you can, like same thing. It's a very famous word is itself tokenization. GPT-2 will not understand tokenization. It knows only token and ization. Okay, but your GPT-4o will know what is tokenization. Okay, that's the point. So
Sir, one
okay,
question. So
yeah,
does
yeah.
that mean in your example, so even GPT-4 or 5 was not able to tokenize Delhi as a single word. So
Yes,
does
yes.
that mean that it is not trained for Delhi as a word?
Yes, in that pre-training data, what was used to train that GPT-4o did not have more number of times the Delhi, the word Delhi. Got me? So I'll explain that with the code, you will understand. I will go to the code, you will understand it little more in detail. So I have run this, you can also run it. So point is, this is tokenization. Just you will leave this. Okay. So tokenization is just breaking of words. Okay. So this is the words. and you break that into small spaces. This is a very simple tokenization you can go through, but this is what is used by GPT. Okay, GPT uses byte pair encoding. This is the uh, token tokenization algorithm. Okay, byte pair encoding is their logic, and how GPT-2 does is the distance between Delhi and Bangalore more than 2,000 kilometers. You see, okay, I'll just zoom it a little more. Okay, so this library, I'll give the code. You can just try and see. So the token IDs. So first and foremost thing, what it does is it will identify the tokens and then create the token IDs for it. Okay. So first it will break the words into tokens, whatever it knows. So knows means what does it know? Like I have seen, right? So if you see, if you give this is the sentence, what does GPT-2 do is it knows is, right? Is it knows, and it knows space the, space the, okay, and it knows space distance, it knows space between, it knows space Bengal, it doesn't know space Bangalore, okay. So Uru it knows, and same way space and it knows, space Delhi it knows, okay. GPT-2 knows. I don't know why GPT-3 did not know.
Sir, actually, I think if the first character is the small one, then it will not able to recognize.
Okay, yeah, yeah, good point. Yeah, that is the point. Okay, yeah, that is it. See, it is having a 50,000 tokens. Okay, so if you go and see what is the maximum number of token ID, it is 50,000 tokens. 50,257, I guess so, if it is exactly correct. So that many number of words it knows exactly with capital and small. Okay, but other than that, it will not know anything, but it can build it from what it knows. That's the point. So build it from what it knows is you give any word in the world, it will build it. Because, like for example, you see here, you see you have given a very big number. I want this number. So you see here. So this is a very big number we are given. It can break into whatever big it knows, bigger words, the maximum size it knows it will capture. Like from starting from 1, it knows for sure 1, it knows 12 also, it knows 3, 123, but it doesn't know 120, 1 2 3 4 1234. Okay, so it will stop this as a token, the known token. Then it will start from the next word. It will try, it knows already 4, it knows 45, but it doesn't know 4 for 56. So it will stop for 45 as next token. Then it will start with 6, it knows 67 also, it knows 678 also, it doesn't know 6798. So it will stop it as 67. Okay, this is how it, this is during inference happening. Okay, but how we are going to train that, how that model learns from that, that we will see. Okay, so this is like the token. I think here if we write 50,000 to 67, we will cross it. So you see, actually, as you go to a bigger number, these many tokens it knows. Okay, so this is a very big word. So if you are very near, like if you see fifth token, it will be like single character. So it will start from single character. By default, first 257 characters, which is part of any English language. I think most of the keyboard characters and all the character single letter characters will be by default. It's in its memory as a token. Okay. After I think 257. Yeah, 257 is also right. 258. Oh no, actually 257 is also double character. If you see, this is space A. So this is 256. This is, I think, correct. 253 is a single character. You see, 254 is again a single character. 255 is again a single character. Yeah, I was right. So it is from 0 to 255. That is the first 256 letters or or by default single characters. Any model knows in BPE algorithm, whichever follows this BPE algorithm for tokenization, will know. But the first token which is formed after that during the pre-training is this word, this letter. So in its pre-training data, the GPT-2's pre-training data had this pair of logic, space T, as the most frequently occurring pair of letters, characters. Okay. So from here you will understand this point that the first after 255, the first token it will create is the most frequently occurring two combination of two characters. Okay, so that is what you will see here. This is the code you can go through. If you didn't understand, we'll discuss it more. So you see here. So if this is the training data, okay, so this is the training data again, just for like wantedly I've given this data just to make sure that if you see, so we were talking about 1,000 books, right? So here we are just training with a simple just 10 or 20 or 15 characters. Okay, so if you have only this as the training data, okay, for your model, how it will create tokens, and first 256 characters are standard. Okay, so the merge requirements are the next three. So you will run this algorithm, BPE algorithm, byte pair encoding algorithm, 3 times on this same sentence, same category. Okay, so what it does is it just merges, like you see here. So for the first time, all these are broken into individual characters, including the space. Okay, and first 256 are given a token IDs, like by default. Starting itself, 0 to 255 token IDs are there. Okay. First iteration, what it does is frequency of pairs. Like you see in this pay papaya, PA is most frequent. 3 times it has occurred at this place, at this place, and this place. All right, 3 times. And AY is 2 times, Y space is 1 time, space P is 1 time. So if you see, the next most probable pair I should merge is PA, because that is happening more time. So merge that pair and create the next token. So now your model should learn PA as one token. Okay. So now the model vocabulary size has increased from 256 to 257 after this iteration. Okay. Now again, after merging, you will again create the pairs. So now you see, you will create this as one token, that is 256. After that, Y will be another token. Sorry, Y will be another token, that is the 121 only, that is same. So all PAs will become 256. Okay, so this is the compressed text. Again, on this compressed text, you will run the same iteration again. You will find the frequency of pair. Now you will consider this as one token. Okay, so the pair is not characters, frequency of tokens. Okay, starting it is by default characters, but after first iteration, this is also one token. Okay, so frequency of tokens. So first token and next token, that is 2 times, and this token and this token 1 time. So now you have to, this is the maximum number of occurring, so you will merge it and then become 257, the next token. Okay, so now you have two words, two tokens you have added to its vocabulary. Okay, so since you have asked here 3 only, so you will have to run that thrice, and finally the latest vocabulary what you will have is this one. This 256 is PA, 257 is pay, 258 is pay. Okay, B is this extra character. So this is pay space. Okay, pay and pay space is different. Okay, so this is another. So based on your current requirement of only 3 merges, this will be given by the training person. Okay, so in our GPT-2, by if you see, this was given as how much? 50,000. Okay, and this training data is like thousands of books. Okay, and that's how you create the tokens. So a basic idea is you find the pair of frequently occurring pairs, because that will help you to create a because you if you are able to compress the frequently occurring, then you will be able to compress every tokens in future, right? User types in anything, you can compress it easily. So more you compress, more faster is your inference. That's why. Okay. So in GPT-3, it is GPT-2, it is 50,000. GPT-4, it would have been like million, 2 million merges. Okay. So because the training data is also very high. Here it is only 3, so that is one. Okay. So here it is, I changed something else, so you can again run that same logic. Okay. So now what I did was made sure this is an India, it's a Word file. I think it will be there. That has gone, I think, reconnected. You know? I'll share that file also. This is just, I wrote it from GPT itself. India text. Okay. So this is a file. You have to, that is the training data. And then you have to give the number of vocabulary size I gave as 512, which is 256 plus 256 means 256 is by default. Okay. And this 256 is going to be the number of iterations which is going to happen. Okay. So once you run it, then it will decode and then tell you. Okay. You see if in that text I have given this sentence also is the distance between this. So after that 512 vocabulary, okay. So you see how it is forming. Okay. Before that training, it would have created letter by letter, I, S, space like that. But after training on that data, it is able to understand S is space, the space, DIST like this, all this. Okay. So if you train it for like maybe another 3 like this, then it will be able to understand each word as one token. Okay. So each word with the space before. Okay, like this is one token. Okay. So that's the point. Hope you understood, right? Simple, right? So it is again increasing the token. You can increase, and then it is why we are doing this is if you are processing inside your transformer individual letter, it will create lot of matrices, right? So computation is required. Computation required is very high. You agree with this, right? You guys have learned the transformers. If you remember that, what do you write? You write QKT by uh, uh, V, right? Not by V, by root of dk into V, right? Transformers. So in that, lot of matrix will be found because every token will be converted into a one vector. So it is better to merge. But if you will create every word as this, what happens is why we don't do that? Why are we doing this BPE is because BPE is subword building. Okay, that's what we would have learned it there in this. So if you see subword units, subword unit helps where it helps is if a user types in a new word, for example, like I tell one word like mega ohm meter. Okay, it's a very rare word. I don't know double M will come or not. I think double M will come. Okay. So if this is a word, this is very rare. Okay. If you ask a GPT-2 also, I don't think this it will be able to understand it as a single word. But this is a very complicated word, right? But it will be able to break because GPT-2 will surely know what is mega, what is ohm, and what is meter. So it will be able to understand mega ohm meter as a 3 tokens. That's the advantage. Even if you write something completely nonsense, right? Like R, Y, C, no, maybe it makes some sense. Sorry. Something which is completely useless. Yeah, OU. Okay. Something. This is consider this word is not at all there in English. Still, it will be able to tokenize this. How? First of all, these kind of rare words is really rare, right? That is why we use the BPE method. BPE method ensures most frequently occurring words are learned first. That is the logic behind that algorithm, right? So like and, the, T, space T, all these are learned. But these kind of words, which is rare, but still it will be able to handle because it knows what is R. It has a token for this. It has a token for this. It has a token for this. Individual letters, it has tokens. So it will still form a tokenization for this. Okay, but it is not worth to understand this complete rare word, right, as one token, which will cost its memory a lot, because every token's embedding will be stored in the model's memory. Okay, that is part of the model's memory. Okay. So that's the point. Okay. So I hope there are three methods. So this is BP is what we have seen, and sentence piece is also code is there. You can go through. And BP is used by GPT. Sentence piece, I think BERT uses sentence piece. Word piece, I mean, this is used by BERT. I think sentence piece is used by. Sure, I never used that. Okay, word piece only we have discussed. Okay, okay. Sentence piece, I am not sure which model uses. You can go to okay, multilingual models, maybe. Okay. So word piece and byte pair, we have code. We can go through. Okay. So this is. I hope you understood what is tokenization, right? So what is the requirement of tokenization and the cost implication behind that?
الو
Understood?
ايه ده طيب ماشي يا حبيبتي في حد هناك طيب ماشي
Okay. Next part is. Oh, you understood tokenization?
Sir, I have a question.
Yeah, yeah.
Could you please go to that example where you gave the random word?
Yeah.
Yeah, so here,
Mhm.
wouldn't in the same BP method, wouldn't the model also have tokens for RY, OTA, ION,
Yeah, yeah.
and it will also
Yeah.
have tokens for just RY, OT. So how would it identify key at this point I should take individual or I should split it into RYO
Oh,
or
okay,
RY
okay.
and OT?
No, 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 you are right actually. Here it will take like that only. I just try to give an example in which there is no combination like this. Okay, for example, okay, suppose there is a very rare combination like this, very, very, very difficult like that. I cannot, humanly, I cannot think. Suppose RYO is not at all a word, RY is also not a combination. Then it will learn individually. Okay, by default, if you go and type this there, where is that? Here, you see here, I type RYOTAIY. Yes, I don't know. I think I wrote this only. So you see, as you mentioned, RY is one token, and this is one token. IO. This is in fact from GPT-3 itself. If you see here, it will again the same, because this is a very rare word, right? So my point is that any unknown word can be tokenized based on this logic of learning, BPE logic. That is why it is called subword units. You
Okay,
got me?
got it, sir.
Okay. So
And
it's
just to conclude, the model would take whichever longest word it has got, right? Like for example, it also
correct,
has R and it has RY, so it would take RY because it's longer.
correct.
Okay,
Yeah,
okay,
that is
understood.
what.
Thank you.
So it will see like this, like it will start with R. So R it already knows, right? So RY also it knows, but RYO it doesn't know. So it will go back and then freeze this as one token. Then it will start with O. O it already knows as one token. OT is also another token in that model. OTA is another token, but OTAI is not another token. So it will conclude this as one token. That's how the tokenization is done on real time. This is done during inferencing. Don't get confused. Okay, this is done during inferencing, but how the training is done is by this method. How the tokens are prepared is done by this. The tokens are prepared by this BPE model. Once these are all the tokens learned. Okay, so when you are trying to query this GPT-2 with a new sentence, it will use all these tokens to break that into this kind of colorful, break into tokens, not colorful, but tokens. Okay, got it?
Yes, sir,
That we
understood.
will
Thank
see
you.
here. Yeah. Okay. So now we'll see text generation by GPT-2. Okay. So these are all installed. I just ran it. I cannot run it again. You can install that. This very simple thing. Maybe it will ask for this the Hugging Face keys. Okay. So you can give that Hugging Face, and we'll see that other one. Just I wanted to give a. You guys can stay for another 10-15 minutes after the class, right? Otherwise, I'll have to have. Well, it's nothing. I'll just show the code only. Nothing to worry about. Okay. So point is that this is the model we are calling it. Okay. So pulling the model. This is the first thing we'll do. Tokenizer. Okay. So any model, first you have to tokenize the words. Okay. So once you take the tokenizer, and what we'll do is whenever you give a prompt, you will tokenize. Tokenizer dot encode means it will take the prompt and then give the numbers. This one. So what it wants is this numbers. This numbers. This is the token number, right? Token IDs. That's called as token ID. So in the earlier case, we would have seen here. This is the token IDs. So this token ID 3031 corresponds to IS. 2029 token ID corresponds to space the, like that. Okay. So when you give a sentence like is the distance between Bangalore, this is this. So the tokenizer dot encode, what it does is it will create this IDs. Okay. What it will do is it will first break that into tokens, and it will find what is the ID for RY, what is the ID for OTA, and what is the ID for OE. Okay. That is simple. Now we'll go back to that. This is how you get the inputs. Okay. So now your model, actual GPT model is after this. Okay. So this is part of the GPT by default. If you pull it, it will come. But actual the transformer model, what we are calling about, is actually after that. The model actually takes this token IDs only. Okay. The token IDs it will take and then check the corresponding vectors. If you remember your transformers, you would have seen for each token ID, you will have one vector, right? So I think in this case, you will have 768 is the embedding the vector size for each token, right? So and that will be sent into the model, and then the output also you will get it as token IDs. The model doesn't know what word you sent. Okay, what is the prompt? The model will convert the tokenizer will convert that prompt you sent into tokens and into token IDs. Okay, the token IDs passed into model, and model ka output also will have token IDs only. Okay, so model ka token IDs will use and then decode it using the tokenizer, and finally you will get the text. Okay. So for example, once upon a time, if I give, so ideally what you see in the screen is the text. Okay, whatever the world with this was created or something. But actually inside what happened is all these steps. Okay. So prompt converted into tokens, tokens converted into token IDs. Token IDs is being processed by the model to generate the output token IDs, and that output token IDs will be decoded by the again the tokenizer as the readable tokens, and the token is just printed here, which looks like words for you. Okay, the token might be which would have come out is like the space world, the space that space was space created, or maybe space create and ed was a separate token, something like that. Okay, so you will just put this there, you will understand. If you put it here, so how the token would have created is luckily we had a space word only, nothing new. Okay, so like this only tokens it would have come. Okay, we can print it from here also. If you want, you can take this output, this one, and then print it individually. Okay, that we can do if you want. Okay, understood now? Something?
Sir, one quick question.
Yeah.
For a given word, will the token ID will always remain unique?
Yes. For the given model, it is a memory of the model, right? For every model, the token ID is constant. It is only during pre-training they would have created the tokens for that model. Understood? So,
Okay.
like for example, GPT-2 I did. So, wait, let me draw it and explain. We'll have some space. So, what happens is you take this is the model. Okay, this is the model. The model is something like this is your GPT. This is your decoder, right? Decoder, which takes your input. Okay. So this is suppose n blocks, decoder blocks, and this is going to give your output. Okay, this is your model. This is your basic frame, like your neural network, like your neural network, you form it, right? This is before pre-training. So next step is, this is your model architecture. Okay. So next is pre-training. So in pre-training, what you do, you take some, suppose 10,000 books text. Okay, not books, books ka text. Okay, 10,000 books ka text. That is that pay papaya logic, right? So that complete text we'll give, and we'll pass it through BPE, create tokens. So tokens means, so tokens and IDs. This is what I do in pre-training, first step. This is first step. So I take this complete text, use this BP algorithm, I create this token. So maybe this is tokens, this is IDs 1, ID 0 to 50,000 to 56, I guess, something like that. Okay. And then maybe 255. Okay. So this is the number of tokens I have created. So now using this tokens only, I am going to train this model. Okay. So now this is the tokens. I will send it to your model. This is the model I'm bringing. Okay, this is the model I'm bringing. Okay, so now using this token, now see this same book text only I will use. So the book text converted by this. Suppose this tokenizer. Okay, this is called, this table is called tokenizer. I will pass it through tokenizer, and then I will get the input IDs. Okay, and this is being actually one more step is there. This token IDs will be converted into static vectors. If you have attended my last semester deep learning, you'll understand. So each input ID will be a static vector. Okay. So how the static vector, I will tell you. It is not actually created this vector. I will tell you one thing. I will tell you the actual thing. It is a matrix. Actually, it is a lookup matrix. It is a lookup matrix for each input ID, means that is 0 to 250, sorry, 50,255. You have vectors. Okay, you're with me. So
Yes,
for
sir.
every input ID, you have vectors. Okay. So now what happens is this vector will be like 768 dimension. So 768 numbers for each token. You will have 768. This is, so for every sentence, like for example in a book, suppose I say what is my name, so that is converted by tokenizer to what space is one word, like that tokens banake. Then it will create the IDs. Then for each ID it will create a this one. So like I'll write one word here. Okay, I'll write something like, just for example, something logically I'll write, otherwise there will be questions on that. Something like um, conversation, very big word. Conversational. Okay, conversational is one word. Okay. So if I see, I will write a small word. So, agent. I will write agent. Agentic A. Okay. For example, if this is the word, this is the sentence in my book, the tokenizer, what it would have done is, uh, consider that it doesn't understand agentic full word. Agent is one token. Next token is IC is one token. Okay. Then next token is space. I'm not drawing an underscore. Space A is another token. Okay, that is how it has covered this. Okay. So this is space. Okay, not underline. Underlining. Okay. The three tokens bun gaya, na? So three tokens ka you will get IDs. Suppose you consider that this is some 50,000 100. Is for this ID it might be like around 400 itself, and this will be somewhere around 7,700. Yeah. So three tokens. For each of the token, you will see in this drawing, in this lookup table, for each of them you will get one vector like this. So maybe like I have drawn it in the other way. You can consider it like this. So since it is matching here, I wanted to just write three vectors. Okay. So just transpose this. Okay. So you will get three token, and this three vector is the starting vector of your in decoder model. The decoder starts here. Okay. The three vectors goes plus the positional encoding in your normal transformer. Nowadays we have rope. Okay. So consider that this embedding added with the positional embedding goes into your decoder where your complete model is there. And finally, it will give you a this last layer, right? A softmax layer. Softmax layer. Finally, it will give one ID. Only one ID it will give. That is the next token. Agentic ID, एक next word predictor. Like transformer is a next word predictor, right? So it will give one ID, and then that ID will be added here, right? There will be four inputs to this, and next ID will be made. Like this, it will keep on going till it sees the end of the sentence, right? So, and these are all the outputs. So till suppose this is the three words it has formed. Okay. This is the output of the model, and these three words will be your the model's output. What you will see in your screen. These three token IDs. The ID only you will get here. Okay, so you will decode it and then write. For example, agent CAI is suppose for example hot topic. For example, something like this. Okay. So these three words are these three IDs vectors which have been created here. Okay. So this is what I was talking about. During this is the training. Training also training. This is formed. Okay, this pre-training. This is getting formed. Okay, and then during training, all these numbers, this 768 numbers, all these are learnt during training, pre-training. Okay, and also the this one. What do you call this? All these weights inside this decoder, how many ever blocks you have, all the weights will be learnt during pre-training. You got me? Pre-training is very easy, right? So you have a fixed sentence and you take half of the sentence. Like for example, what is my name? My name, correct? So this is the sentence in your books, in this book. Okay. So what we'll take by default is we'll take one word, this word, and predict this word. Okay, so you pass only what here and whether this model is predicting token for is or not. Okay, next you will pass what is and then predict this word, and we'll pass what is my and then predict this word. Okay, that correction you will do. Okay, so once you it will surely not predict at the starting because starting all the weights are random, right? So initialized weights. So that is how it comes. Okay, so I have already gone through the transformers. Hope I answered your question, right?
Yes, sir.
Fine. Okay. Okay. Next, this is the transformers which you would have, which I have already also explained now. Just you go through your deep learning paper also, course also. Simple thing, self attention. You don't need to worry about that. We'll not ask anything about self attention, but understand that's like last semester tech, I was teaching that, but I thought more agentic logics we have to use, right? In enterprise, you don't need to know exactly what it is, but you should know because if you wanted to play with the inner blocks, if you are customizing, if you are doing fine tuning, understanding self attention is useful. And since you have learned it in deep learning course, I just skipped it here. So this is the part. So from transformer, so this is what I was talking about, right? So from starting from transformer architecture in 2017, so we pre-train using massive text data, like thousands or 10,000 books. Okay, so what basically pre-training does is it makes that what it ensures that the model is able to output the next word correctly, the most expected next word correctly. But that is what pre-training does. If you remember in your deep learning also, that's what we learn. But what is next step is what the chat GPT structure. Actual models have. But your GPT is not will not be stopped there. They will do a thing called so what I was talking about here was so first is the model architecture which they create and they do the pre-training. After this complete pre-training, right? So the model will be able to predict the next word properly. Okay. So if I say what is my, it will be able to say that okay, space name is the next word. And whatever you think like okay, what is my name means it has to give output Bhagath. Okay. But for the model, it is just the next word. So what is my name? Bhagath. For model, it is like this. For you, it is an answer. This is an answer for you. But for model, it is the next word after these four words, four tokens. Okay. So understand it in that perspective. So point is now, till pre-training, it has understood to predict the next word after the name, right? So after this, what they will do is they will do a supervised fine tuning. So why you need a supervised fine tuning is now the model will be able to predict the next word, right? But it doesn't serve any purpose. It is to be it has to learn to give an output, proper output, right? So you wanted it to give a very nice response to a question. So you train the model to the same pre-trained model. Pre-trained model is the main base. You cannot change that drastically. You have to just train only the final few layers, or you can train some of the intermediate layers also to ensure that it gives in a instructive way. Like for example, in a good format. Like you ask a question, it knows to give an answer. Like it already knows Bhagat is the answer, but you will tell it to give in a little bit different way. Okay, your name is Bhagat, so it's like that. It will not just spit it out like what is your name means Bhagat. No, it is the next word, but you don't want that kind of answer, right? You wanted the model to reply a little bit naturally. Say they do this SFT. Okay. So I guess we'll see this little later details. Okay, SFT, and then there is one more thing called RLHF. In RLHF, there are different methods. RLHF is reinforced learning, right? Human feedback. So human feedback is also there. So there are some methods we'll see in our further lectures. PPO, DPO, GRPO. GRPO became famous after DeepSeek came. Okay. So and ORPO is also there. We'll see that. Okay. So this is like a bit important. This is very, very important because this is how the first chat GPT was made. Okay, DPO is like little bit shortcut. This actually does not belong to RLHF, but we'll learn there. GRPO is interesting because it's part of this one, and ORPO is also there. Nowadays, agentic also agentic name, so reasoning models. So reasoning models helps. So GRPO also helps this reasoning model. So apart from teaching the model, see after pre-training is like a raw text output. Okay, so SFT will give you little bit instructions, but this RLHF will give you brain to the model. So it's not like brain; it will thinking tokens. That's what we call it as thinking tokens. So instead of outputting the answer directly, we will try to output the thinking token step by step way. Like mathematically, maybe if you are asking 2 plus 3, it will give you 5. 2 years before model, but today it will not give you 5. It will see okay, what is 2? 2 is a number, 3 is a number, and plus is an addition factor. So what should I do? So now it is an requirement as addition. So now I will add it as 2 plus 3. Very simple example I said, but when you ask a very complicated mathematical question, this kind of thinking tokens are very important before you give the final answer. So those things are trained at this stage, the RLF stage, okay, RLHF stage. So SFT is to obey instructions. RLHF is to think, okay, think and then reply. Okay, so that's very helpful. And finally, what you get nowadays, most of the models, bigger models you get are at the end of this. Even small SLMs you get, you will get here. But some of the Hugging Face models, you will directly get pre-trained model. Those are all called PTMs. Okay, pre-trained models. Okay, so those are all very raw. So you have to do this SFT and RLHF for your use case. So if you wanted to, instead of taking this costly model, or maybe say this, if they would have trained it for your use case, you can pull this model at this after this RLHF. But if you wanted to take a base model, pre-trained model, because you cannot create one model architecture and do the pre-training, that is very difficult. If you have computation, you can do that also. But if you are wanting to just specialize a model for a particular domain case, it's better to take the PTM and then do this SFT yourself and RLHF yourself. That's what we will learn it in our fine tuning lectures. Okay. So this is done. Okay, already we showed it up. Just few more slides. Agentic conversation. Okay. So this is just an introduction I want to give. We will see agents very in detail. I'll take another 5 minutes. Okay. Sorry for that. I speak a lot, right? Okay. So agentic conversation. What does it happen? It starts with a. Let's have for today. Give me 5 minutes. Okay, I'll finish up. This is nothing. Okay. Just you can go through this very quickly, or I will do one thing. The code is more important than this. So once you know to text generate, okay, this is just showcase. This is nothing to learn from here. Give me 5 minutes. This will end up this stuff. Okay. Anyway, sorry for that. Okay. Okay. Thanks. Okay. So what I have done here is take a pull up as GPT-2 model. Okay. And without using tools means just check how it is trained. Okay. So GPT-2 model means what I am talking here is after it has been pre-trained, after it has been SFT, after it has done RLHF. Okay. So it is not so much thinking, it doesn't have so much thinking power. It was done with PPO method. Okay. Maybe it was done with PPO, or maybe GPT-2 is not at all done with RLHF. It is stopped after SFT itself. Okay. Okay, so now this is a very simple model with SFT. It will know to obey some question, listen to some question and give an answer. So that is the limit, right? So it will just output text. Okay. So now then what I have done is I used Pydantic. That is a way to extract uh, structured output from a very old model. Okay. Even today, bigger models we use Pydantic, but older model you have to do 2-3 iterations to get a very structured output, even for Pydantic. Okay, Pydantic is like in a very short form. What I can say is it defines a structure, right? So, for example, I said tool in JSON format. I am asking tool, right? Tool name. Give me a tool name. What I have to refer. Okay, so that is the requirement of Pydantic. So the model output, whether it matches that tool name JSON format or not. If it doesn't, then again you send it to the model saying that no, it has not. You have not given a correct format. Give me again. So you'll keep on iterating. So that is what is Python. It's very simple. It's a very simple Python logic. You can go through this and then you. So what I have done is I use Pydantic to get an output whether for a given query GPT-2 can give a response or not. Okay. So if it doesn't able to give the response from its own memory, it will tell what is the tool I have to refer. Okay. Here I have given only one tool. So it will itself answer, or it will tell, okay, it is tool is required. Okay. And GPT-2 with a tool call you will do. The tool is the weather API, which I have taken from Tevel. Okay, so you can also take this; it's free. Okay, and then once the GPT says, okay, no, you have to refer to the weather and give me the output, I will frame a very nice natural language response for you. Okay, so you will go to the Teveli, you will use this Teveli, and then get the response to this LLM GPT-2 only, and it will just create a natural language answer. That is what the complete stuff is. So you can see this is the base model. So here you see function name, location. So location. So because the, what this API weather API does is it requires a city's name. So if you give a city's name and it goes into GPT-2, right? GPT-2 has to give two results. One is the city's name from the user's natural language. Another one is the function name. What is the tool it has to call? Okay, so that is why. And why it is not mandatory, but you can call it. So this is how it has to type string location it has to give. Okay, location it will take NG. Okay, now we go to the final answer. So this is the stage 1 baseline. Stage 2 is tool definition we are given. Tool 3 is selection based on the GPT-2's reply. Fallback is, as I mentioned, GPT-2 is a very bad model. It will not perform in one time. You have to keep on iterating. Okay, so that is why it's fallback mechanism. And you'll call the, how do you call the weather API? Okay, so I have the client, right? I have the key, and then you call the point. Just use that query location you give. This is the same query you will send it to API. Only the location has been extracted from the user query. Okay, so we'll see that. Okay, if you run here, so when I run this, okay, the question was, so the question, what is the weather like in Mumbai? This is the user query. Okay, so stage 1 it runs, stage 2 it runs like that. Okay, so what happens is in these 5-stage demonstration baseline without tools. So if you see GPT-2 obviously cannot access. So what's the weather like if you ask GPT-2? It gives a very useless answer. It's a bit of mess. The wind is blowing and the sky is cloudy. This doesn't help, right? So this is not actually, first of all, real time, because GPT-2 cannot give a answer as on today, right? That's itself incorrect. So weather assistants will obviously will tell that it is wrong. Right? We have an evaluation framework also. So now what happens is it has no access to the current weather data. So that is why now what we are telling is we are defining the tool. Like tool means the API, weather API, and then now telling to select GPT-2 will take the query, what's the weather like, and then try to decode it and find the location what they are asking. Okay. So from this complete sentence, whatever way you ask in the sentence, whether what's the weather in Mumbai, and and something like a very complicated sentence also, GPT-2's work is to identify the location in this complete sentence. Okay, so you see 2 times I think it has failed. That is why we have a fallback mechanism, and finally it has found that Mumbai is the word in that sentence. Okay, so once that is Mumbai is the word, then this word is sent to the weather API, the Taveli, okay, and then that will give a reply. So that will give a very detailed reply. Okay, so this reply you can read. Okay, so that reply you will get, and that reply is shared to the what do you call, to the GPT, and then finally it is going to give you a natural language reply. This is GPT-2 is very poor in understanding also, because it's very old model, right? So that is why what I did was Gemini is a free model. You can also access Gemini 2.5. I have taken. So you can take this free model. I think 2.2, 2.2 Flash. This is very latest model I have used. Okay. So if instead of, say, this complete code, after that is just that instead of GPT-2 in the previous case, I've used Gemini. So in this, if you see, it will immediately give a very correct answer, not from itself, because 2.5 will not be able to give the answer immediately. Immediately means from its own memory. It has to also call the tool, because it will not have its current weather data, right? So that is what. So Gemini cannot access. So it will give an answer, but it is not a current data. Cannot provide current and accurate weather. So it will go into the thing, and then again it will go the raw JSON from Gemini. So you see, Gemini has given a very good JSON output, which GPT-2 could not give. So it told that your action, what it should do is call the function. Which function you have to call? Function name, get weather, get current weather, and the argument what you have to pass to this get weather function is Mumbai. Okay, so only these two are very important, because if you go back to that get weather function, right? So we'll understand that from there. Mm, so this is the get weather function, right? So when you give this location, first that is sufficient. This is the query form, and that you are sending to that API, and you can get a very correct response, right? Because you have a very good structured input. So location is coming from the Gemini's response, and query is formed, and you have the API key. So you call the real-time weather API and get the real-time data, and then you will send it as a weather information. Okay, so the weather information, when it comes, taking so much time. Thanks for you guys being okay. This I finished in 2 3 minutes. So finally, you got this as the output. Successfully parsed the. So if you get such a very nicely framed output from a LLM model, which is very difficult 2 years before, but nowadays all LLMs can give this. Okay, most of the LLMs can give this. So you can easily parse, right? You know what is to be done. So now you can do everything else based on this. So it is able to decode that whatever way he asked. Maybe he asked in Hindi, he asked in any other local language. It will be able to give you this data, Mumbai and current weather. So then you can send that to API and get the result from there, and then you can pass it to this one, and then you see Gemini has given a perfect result. As on today, it is currently 31 degrees. So point is that Gemini JSON mode ensures reliable structured output. So reliable structured output, if you get, you can easily take it into production. Okay. This is the main catch which we didn't have it earlier. This one. Most of the bigger models is able to give. Then just one other things are just normal, right? This is just programmatically. You have the structured output means you can pass as an argument to this, and then you can call it. And now little more we will do. That is later we will see. MCP is 2 steps ahead of this. Okay. 2 steps, 1 step ahead of this. Okay. So that's the point. This is same thing. Okay.
Bhagat, where are you passing the tool information to Gemini?
In this last function. In this function. So answer response generation, if you see, you will get the query and the weather data which came from the API and the location, which is Mumbai. So this is the original query from user. This is the weather data which came from the API call, and then this is the location. So all these things, if you pass it as a prompt, right? This is the prompt. This is the user-friendly prompt. So you say that this user asked this query and retrieved weather information from the API is this one. Okay. And based on this retrieved information, extract the key weather and then present the information in a friendly way. Okay. Just that the answer will be generated by it. It is just for natural language, natural response. Got
Okay.
it?
Yeah. Because I was trying to correlate with MCPs. That's why I asked this question.
MCP is little bit 1 step ahead. We'll discuss that later.
Yeah. Sure.
Sir,
Okay.
where
Yeah.
this is very specific to like where is that code which extract the location? I mean,
Extracting the location is done by the GPT, right? So you go to GPT, this is the tool selection. So this is the prompt, right? This is the query. This is the tool. This is the user query. This is the tool. Okay. And this is the prompt you are making. You are a decision making assistant. You are making the Gemini as a decision making assistant. Okay. So analyze the user query and decide if you need to call a weather function or not. Okay, so you are giving all this in a natural language. So this is the tool name, this is the tool description. So you have to give, right, what is the tool doing, right? It'll understand from you, and this is your user query. So you pass, and then you wanted it to give it in this format. So you are explaining it like this. This is the format I wanted you to give as an output. Okay. So rules, some of the instructions you can give. So give a clear reasoning why you have chosen. And if you want, like you can also write if it is in other language, first convert it into English and then try to understand what is the language, what is the correct location. Okay. All these instructions you can give. And this complete output only in JSON format. This is your prompt, right? This is your prompt. You have made this prompt, and this prompt you are calling Gemini.
Okay, sir.
So
This is some app we want to develop, which can be like very specific for weather, right? I mean, we give if user
This is
queries.
only for weather, but you
Hmm.
can add another 10 tools like this here. So here
Okay.
available tool is only one, right? So if I will add another some tools here, okay, for example, like this is tool number one, right? So like this, three tools I have. So this is weather tool. I will tell some other tool. Suppose maybe I want to understand forecast. Sorry, not forecast. Share market. Okay, share market. And this is another tool for something else. Maybe bits marks, something like that. Okay, just joking. So based on the query, it will analyze the query and then try to understand which tool I have to call. It will give only one output. You can ask for more than one tool also, but you can make it simple, like out of these three tools, so two questions you will tell it to do. Okay, one is whether it itself can answer or not. If it can't answer, tell me which of the three tools it you want me to call. Okay, so you ask it to tell. So it will give it in this format, right? So in this format, you can easily understand. Location is there, exact location, function name is there. So you have three functions here. Currently, I have only get the current for the function. So you have another two functions here. So whichever tool function it says, you go and call that, get that information from that tool, and then again pass it to Gemini to generate a response. Got it?
Sure, sir. Got it.
Right? So bigger the model, more number of tools you can. It's not like every model will not take 3 4 tools. Gemini 2.5, of course, it will take. But if you go for some SLMs, it can only decide whether I have to call a tool or not. So that's what I was talking in the starting of the class. If you are having a very small SLM, it will only decide yes or no. Okay, understand? So you have to restrict the prompts. You cannot make some 10 tools. You cannot pass some 10 tools to a SLM and ask it, okay, select the tool. It will start hallucinating. Okay, the prompt also, it cannot be so big. So that's why bigger the model, it will be more good. But whether it is required or not. So in this case, for my use case at this point, it is just one tool, right? So for this, even GPT-2 could have performed, but it didn't perform. Only thing is, I could have made it a fallback mechanism 10 times. So it will take more time, but it would have done the work. So why to call such a big model, right? So maybe GPT-3 would have 100% done it. So I don't require Gemini 2.5, which is very, very big, or GPT-5, which is very, very big, right? So cost optimization comes there. That's a
Uh,
small point of cost.
Sir, one more thing.
Yeah,
Here
yeah.
we are calling external API for Tabili, right? For the
Mhm.
weather information.
Correct.
Can we say that this is a RAG kind of a model, or no? We can't say.
No, no. RAG is like it is you are bringing some information. This is also information. That is a retrieval process. RAG is a retrieval process, right? So this, see, even in, like for example, see, what does this tool do? Okay, what does this Gemini does here is tells you, okay, you call this function with this argument. Correct? You agree with me?
Right. Right.
Correct. So exactly, you can do that. So instead of this get weather stuff, I can write one function like this. Def, oh sorry, there is by default I pressed it. Sorry, RAG pipeline. Okay, something like that. Okay, I return response. Okay, oops, initially, oops, what happened? Ooh, shit, I deleted it, yeah. Oh, what did I do? I deleted.
Hmm?
I deleted that function.
Sir, just checking one thing. So are you going
Okay,
to
okay.
share this file as well?
Yeah. It's simple, right? So what I okay, let me finish what I was trying to explain. So this is the query return response. So what I was trying to say is, so suppose your Gemini is the first call, right? The tool selection that if that Gemini call is an intent classifier, okay, that intent classifier will decide whether for that particular query you have to go to the RAG pipeline or not. Okay, so that Gemini will give an output response saying that yes, you need to go for RAG, which means it will output just like this, right? So instead of this kind of reply, it will say that okay, RAG pipeline. So this will be its
Right.
output, and then instead of this, it will say that it don't need to say that okay, maybe it is like additional instruction, something like that. Okay, because user query is already there. Okay, so additional information. Maybe Gemini want to add something with the user query. It is like clarification, right? Appending some additional information more than user query. So something like that. So it will whatever it wants to add. Okay, some information. Okay. So if you ask like this, so once this kind of reply comes, right? So you can pass this additional information and then call this function rack pipeline. And inside that function, you can call any rack pipeline. You can use pinecone, PV8, quadrant, whatever you want, you can call, and you can use all these things, right? Additional information, and then what else you want? You can tell maybe it is either DB, right? Either it is DB or it is this one doc search, something like that. Okay. So it is whatever you can take this also one variable from Gemini and then pass. Okay, and then inside this function you can call the your vector database pipeline. Got it?
Sure, sir. Basically, adding some more information. Yeah, that's, I mean, through the right pipeline.
Right. No, it is. This is not mandatory.
Mhm.
Mandatory is to identify using Gemini whether for a given query I have to call drag pipeline or not.
Or not.
Got
Okay.
it? So
Hmm.
that can be done by Gemini. Additional information is I added from me. Ideally, it is required. When you go in depth, you will accept that this point is valid. But this is not mandatory. Mandatory is this one. Mandatory requirement is Gemini decides whether for a particular query I have to call rack pipeline or simply it it can only answer. Suppose like I was talking about SLMs, right? Initially, intent classification. So user says hi. So why do you have to go and disturb your vector DB for a query of hi, right? So hi, any SLM can reply. Gemini will surely reply, correct? It will say hello. So you don't need to call a very costly vector DB. You will have to spend money, right? Every call to your vector DB.
Sure, sir.
Agreed.
Got it.
Okay, yeah. I think mm, okay, done. I think this one I will go through next week also. This is a very small example I put it. Okay, and other things I have done. So these protocols and all this is just a introduction. Okay, so we will go through all these things in detail. So basically, the first lecture is just introduction. Uh, from this, if you want to take away something, the main important thing is understand that this intent is very important. Okay, this is the first step. And another thing is structured output helps you to call tools. Tools can be anything. Like our friend told that it can be rack pipeline also, it can be a API also, It can be your DB call also. It can be your doc search also. Anything. Okay. And then memory, we will. You don't need to worry about as of now. We will discuss that in detail. Okay. Planning, safety, and all we will discuss. Okay. This intent, tool, understanding. These two you should remember. Remaining things just go through. Okay. Okay. I'm sorry, but thanks for staying late. I'll reply for this query. Okay. Thank you all.